So we'll create a Titanfall like wall running mechanic. There are some problems I've seen with wall running and I've come up with different solutions. I've added some details that makes the wall run more precise. I want player to really stick to the wall easily and get a smooth experience like in Titanfall 2. So the first problem with wall running is you have to look straight ahead to go forward. I'll explain this in more detail. Second is that you can't start the wall run so easily. You have to really touch the wall at a certain angle. And another problem is you fall off the wall too quick. Before looking at the code, I'll show you my footage from Titanfall 2 so you could get a better idea.
Hang on. I want to run it some more.
No problem. I'll be here when you're ready. Personal best.
Okay, so let's check the problem. We are looking like this, but we will wall run like this and we will fall down. That's a problem. Why this happening? Because we are using this vector as player's forward vector. I mean, if we are using the direction vector in wall run as player's forward vector, we will have this problem. And if you look at this will not be a problem because you will get nearly good vector that you can move you. So if you will look like this, it will make you move forward. But now the problem is we are not seeing the game itself. I mean, if you are playing a game, you cannot keep your mouse like this. So what are we going to do is use the wall's forward vector. So it will move us parallel to the wall always, wherever we look at it. And we will get this by using wall's normal vector. You can think the normal vector as the perpendicular vector coming out of a plane. When you look at this image, when we jump at this side of the wall, normal vector will give us 1. When we jump the other side of the wall, normal vector will give us -1. We are going to hit a wall from left side. I mean, the wall will be in our left. So left wall hit normal.x will be greater than 0. And we will say wall run direction is transform forward of the saved wall. If we hit from other side, the normal of x will be -1. So we will say negative left wall hit transform that forward. That will be our wall run direction. And we will use the wall run direction in move player function. So if we are wall running, we will use this function. So if we check out the game, even though I'm looking at this side, you can see it's still green. Look at this. I can watch what's happening on the game and I'm still wall running at the same speed because I'm using this wall's forward vector. I mean, which is amazing because you will not look like this in a game. You have to look here. So you can see only when I'm perpendicular to the wall run stops. Yeah, this is very good. Okay, so let's look at the next problem. I want player to stick to the wall. Actually, it's my whole philosophy on this project. I want player to stick to the wall, and unless player moves forwards or jumps, it will stick to the wall. You can change it, you can make a different approach, but this is the one I'm using right now because I don't wanna think about wall running. I just want to jump a wall and let it handle its course itself. So you can see the gizmos here. Let me focus on here. You can see the red line. That's the wall run check. If we get close to the wall this much, the wall run will start. And you can see we are getting pulled to the wall. So if we increase this value, wall pull force. Okay, we are not getting pulled to the wall. That's weird. Okay, now we are really getting pulled. Okay, so you will see when we jump, we getting pulled to the wall. I mean, if we increase this, we will probably get inside the wall. I'm not sure. Let us see. Okay, no. Because I'm using continuous collision, it didn't get inside. But the main thing is, when I get close to the wall, I will just stick to the wall. So I increase the wall run distance, you will see it better now. And bam, I'm stick to the wall. So I'm jumping here, bam, I'm stick to the wall. So it's really easier, and I think it's much more fun when you do it like that. I mean, I left the wall running to the game instead of doing it myself. You will see I'm using add force, wall pull force codes to move the player to the wall. Okay, the last thing, I'm using custom gravity, not the gravity rigid body has. And when I'm wall running, I'm using another gravity to fall wall run so player doesn't fall down easily. You can change it, you can tweak it and add more stuff, but I want player to stick on the wall, so I have used the custom wall gravity. And you can check out the value from here. Okay, let me fall down. It is 0.2. Let's make it 0 and see it. Okay, so player doesn't fall down and goes up actually. So player going a little up because it has upward force when we jump to the wall. And it might fall a little down. Even though there is no gravity, it has a downward force because we are falling down. So you can tweak these settings and add a little bit more to show you the code. So I'm using a custom gravity that is 25. Wall run gravity that is 0.2. And you can see when we are wall running, it adds wall run gravity down. So we are falling down. But the value is so low that we are not falling down actually. And wall run is precise, but since we are using add force, not velocity, because of the rigid body, you can check here, we are using add force. So you will go like something like this. Move direction dot normalize. Move speed. I mean, at least something like this, but you should try out. I will try out the rigid body velocity version too, but right now I'm okay with add force. That's it. We can wall run, we can look at the game, we are going fast and we are sticking to the wall, and we can double jump and go to the another wall. If you are going to go over the code quickly, we got a lot of different variables. You can check it out. And in start, I'm making can jump through, getting the rigid body reference, freezing the rotation. And in update function, I'm sending two debug draw race to understand what's going on and checking if we are grounded, handling the input, handling the jump and double jump, and checking if we are wall running. And let's go to the wall running function. If there's a wall on left or if there's a wall on our right, we will start to the wall run. And to understand that, it's really easy actually. We are just sending one ray to each side to understand if there's an object with layer wall that has a collider on it. And if there is one, we will say we are wall running. And in wall run function, we will add gravity force to the dam and we will make is wall running flag true. Let's just check the left side. If we are not pulled to the wall, we will change the flag to true and we will check the current wall. We will change the materials and you know this stuff. We will pull ourselves to the wall and decide the forward wall run direction, and we will tilt the camera. And while we are running, if we are gonna jump, we will do this code. We will check Wallrun jump direction according to the normal of the wall, and we will add a classic force to our object. And after stopping Wallrun, we are changing the material back to black. After that, we are changing the Wallrun tilt and our flex. And I'm using a classic jump function and double jump function. And for moving the player, I'm getting the input. And after getting the input, I'm using an add force to move the player. Okay, so this is it. And I think this Wallrun is acceptable.
It is acceptable.
If you want me to add more stuff or if you have any questions, please comment. You should like and subscribe the video to get more of this content. I have different plans and wanna create different videos. If you have any ideas and want something me to create, I can look at it if you write. And you can get my indie game Beşli Parti from Steam. If you play it, leave a comment and give me some feedback. It will be great.